Welcome back to another HVAC-Engineering-Techie video. Today's video is a little different. It's about guaranteed building performance. This video would be for somebody who has responsibility for building performance, builds building and hasn't been getting building performance, would like to understand how to actually guarantee that this building works the way it's supposed to. Now, I've spent my whole career working on buildings that don't work correctly, weren't built correctly, weren't operated correctly. And we've done that through commissioning new buildings, retro-commissioning existing buildings, general repair and rebuild and refurbishing old buildings. It turns out that our building stock does not work like it was intended. There's a whole bunch of reasons why, and basically is the system is rigged against that. If you actually get a building that works correctly, you should thank your lucky stars, because it doesn't happen very often. So what is guaranteed building performance? That's what we're going to talk about today in today's video. And remember, this channel talks about all things HVAC, and building performance is one of them. So before we start, sure like you to become a subscribing member to help me along my way. Give me a thumbs up if you would, and push the subscribe button down below. Cost you nothing, it's painless, but it really helps me because Google uses that data to evaluate this channel. So I'd really appreciate it. So let's talk about guaranteed building performance. What is building performance? First thing we need to do is define what actually do we mean by building performance, so we're all on the same page. So one, building performance means the building actually meets the owner's project requirements. What did he actually want? And he needs to define that in the OPR, which is clearly defined in our commissioning videos. So number one, it meets the OPR. Two, it has IEQ performance, which is indoor environmental quality, which means basically it has occupant comfort, their comfort, temperature and humidity is good in the building, indoor air quality, so it doesn't have any fumes that cause them problems or dust. Space lighting level and quality is good. Acoustic is good. It's not so noisy or vibration. You can't work in the space. Energy and water use meets its intended goals. If this value was said that this building, if the design said it's going to use this much energy, it needs to use that much energy, which means the energy modeling must be correct. Meet selected baselines. We expect this to, when an owner builds a building, he's planning for it to have this much utility cost. And if you build a building and that utility cost is twice, now his budget is totally shot. So it needs to meet those baselines. So what level do you want? A building, just like grades in school, it can have a good building or bad building. So what do you want for your building? You want an A building? I'm sure you do. You probably wouldn't build it. I'm sure not going to build one for an F rating. But many buildings get F ratings all the time. It's really sad that when we've, I'm a technical commissioner, and I believe that that's a process that actually gets you a working building rather than a process commissioner. We're just not going through the actions of pretending we're actually making a difference. We're actually trying to make a difference in the building. There's a lot of obstacles to that, but that's what we're trying to do. Now, I've been a proponent of technical commissioning my whole career, and this is kind of what this video has grown out of, is seeing buildings not working and how can we actually make them work. So why do we need guaranteed performance? All right, this is a study that was done some time ago in 2008, and this is of LEED certified buildings. And this is kind of a scatter diagram showing you this is the design EUI, which is energy use intensity, and this is the actual measurement EUI. And you can see, if everything was perfect, it'd be right on the line. So this is kind of like a shotgun shell. It's a random pattern, which is not good, because a random pattern means a 50-50 chance you could be anywhere. You could actually be above or you could be below. That's not good. There needs to be a rhyme or reason of why we're not getting to where our design is. Our design is this black line, and they're all over the place. So this is the actual measured versus proposed savings percentage. So you see this is the design, and we have several buildings here that are, this was our certification level. And then we have several buildings down here, this is less than the base case. So, in the LEED world, you take and you design a building for the lowest acceptable system. The worst system you could put in the building and still meet 90.1 energy standard. So if you could, this is say a package unit system, and this is the worst system, we can still barely meet that criteria. That's your base system. And then you design a really good system, and that's your intended system. Well, these points down here don't even match. These are way below the baseline. So there's something seriously wrong with these buildings. So this is why we need to do this. This random pattern is not acceptable. We don't want our building performance to be luck. Now, to tell you the truth, a lot of these systems up here that are doing a lot better are probably because the building is not occupied. A lot of these buildings are measured. Their performance is determined before the building actually gets to design occupancy. Especially if it's a lease building, then it may take months or years to get that building up to its lease condition. It's very difficult to tell how a building is performing when it's empty. Very, very difficult. So this could be some of that condition up there. Of course, some of them could be doing a great job. You don't know. So this is the 121 buildings involved. Now, they've done studies since then that show similar patterns. And the study they did after this, they came up with a conclusion that their modeling was inadequate. Well, my comment to that always has been, and the modelers at ASHRAE have actually said that you can't use our model to determine what a building will actually do. And I'm going, why do we even model if we don't do that? But telling the truth is the same models they're talking about have been used for years by ESCOs, guaranteeing energy performance through an ESCO. And so they've been living by that model, so why can't you? I think that's a scapegoat, because I don't think they realize the problems of actually getting a building to perform. Okay, why don't they perform better? We have better designs. We keep getting better and better and better at design. We have more efficient equipment and systems. Our systems are actually more efficient. Don't know why that we don't end up with better results. We have better materials. I think we're getting better at building enclosures and building envelopes. We have better construction techniques. We certainly have techniques that lower costs, but why don't we reach our performance goals? The prevalence of lowest possible cost mindset instead of quality performance. So basically, I've been a contractor a long time. I started out in engineering, and then I began into contracting, and there's a problem with contracting in that it's hard to make a profit. You may think that contracting is a method to get rich quick, but it is not. It's hard to make a profit. And so that profit motive is a consistent pressure on a contractor to figure out how to make some more money in the job. So that lowest cost mindset prevails the industry. You can be $10 low on a bid and get a job, or be $10 high and lose a job, even though you by far the most qualified contractor. They don't look at that sort of thing. They look at cost first, absolutely first. That's a problem. Compressed construction schedules impact testing and commissioning. It happens on almost every job. The contractors will start losing days during the construction. Well, those lost days are not normally added to the end date. The end date stays the same, and the contractor is expected to escalate things along the way to make up for that lost time. And normally what happens is they impact that end date, which is when all our testing and final commissioning is done. And we get compacted into trying to do that while it's occupied, which you should not do. So that's another the reason why we have poor performance. Value engineering for cost reduction with no regard to performance. This is one we've seen many, many times where a contractor come out and say, Mr. I can save you $20,000 if we just switch to this item here. And they look like they're just the same. But if you dig a little deeper, you might find a performance issue. And those are normally not looked at. It's all about cost. I've seen this happen where it's cost the owner hundreds of thousands of dollars in the first 2 or 3 years because it was a stupid move, but no one looked at it. They only looked at the cost. Poor enclosure construction quality for air leaks. We're getting better at that, and some states are starting to realize that a leaky building is a high energy use building. And if you really want low energy and better performance, you need to build a really good enclosure. So people are starting to pay attention to that, but we need to pay more attention to it. Poorly performed tab. Test and balance of the HVAC is one of the lowest cost subcontractors on the job. Most general contractors don't even bother to look at it because it's so low cost, but it can have a major impact on performance if it's done incorrectly. So guess what? How we buy this service? Absolute low dollar. It's ridiculous. You have a contract that on a $20 million building maybe is $20,000, $25,000. And we would, for $10, we'll give that to a non-qualified person. That's absolutely stupid. And that actually should change. But, we live in a world of this low-cost mentality. Poorly performed commissioning with little actual testing. The process commissioning really has hurt the commissioning business. Commissioning started out as an industrial exercise, mainly because if it didn't work right, someone might get killed. So you spend a lot of attention commissioning something, make sure it works if someone's going to get killed if it doesn't work. So, but those days are gone for HVAC. When it came into commercial buildings, it now is a paper process of just taking a piece of paper and said someone else told me it works. It doesn't work at all. So we need to up our commissioning activities to actually test the building and actually be involved in actually making the building work correctly. Why is performance not delivered again? Design team, low level of field services. We stopped that because it costs money. Inadequate operator training for performance operations. The way we train our operators in some places is absolutely stupid. They need to know how to operate this building because an operator can destroy performance very, very easily and very quickly, and they may do it because of ignorance, and that should not happen. Operators left to diagnose and deal with poor performance from delivered systems. So if you're a building owner and you have operators and you get a building that doesn't work, well, your operators are tasked then with figuring it out and making it work. And that sometimes is problematic. One, they don't have time. Number two, they may not have the skill or the knowledge to do that. No performance tracking system installed or utilized. Most buildings do not track performance other than the owner saying, man, this bill's too high. That we get. But to actually track it and figure out why it's not right and how to correct it, we don't do. And that's unfortunate because it's not that hard to do. So who gets penalized if it doesn't work correctly? Only the owner. If a contractor builds a building and it looks good, it meets the space requirements, the temperature's reasonable inside the building, but the power bill's 1.5 times what everyone said it would be, he doesn't get penalized. Only the owner. He has to pay the bill, so he gets penalized. For contractor designers, no money changes hands for poor performance. It's not there. So in current construction contracts, performance is implied but not actually contractual. There's nothing in the contract that says a contractor is going to owe money if this thing doesn't perform correctly. It's not in there. It's implied that we're going to build a good building, but it's not actually contractual. And that's their problem. Now, there's a reason why it's not, and we will get into that. So how do you make performance contractual? Change the construction contract so there are 3 milestones to be achieved. Budget, which is already there. Schedule, which is certainly already there. And performance, the third one. So now the drawings and specifications lay out the framework for what the building's going to look like, the size and all the things, all the amenities it's going to have, and this contract details what it's going to cost and details when it's going to be built and when it's going to be done, and it should include what the performance is and how we're going to get there. And that's what is not there. So it sounds easy, but it takes more than just a simple contract change. To hold a contractor responsible for performance, you need to use a total project concept, and I will explain what that is. And that's why this has not been done before, because we don't have a single contract. We have silos, basically. So we have an owner, and the owner has certain responsibilities for building a building, and he's going to look at how he's going to get the job. He's going to low bid it, or else he's going to negotiate it. He's got develop the OPR. He has to do that, and then he has to select a design team. So the things that he's responsible for, and then the design team. They're going to, they're going to have a budget. They're going to energy modeling. They're going to equipment selection. They're going to do the design, and they're going to do system selection. So they got a lot of things they're going to do here, and it's going to be commissioned normally. And then we have the contractors, and they're going to be, you select a general contractor and you select a quality plumbing contractor, electrical contractor, mechanical contractor. And the quality of these firms is going to directly impact the quality of your building. If you get a general contractor that builds sloppy buildings, you're going to have a hard time. Or if you get some of these subcontractors, these major subcontractors that don't do a good job, it's going to hurt you. Quality, enclosure, you have to have a good enclosure. You have to have a good plumbing, electrical, mechanical. You need to start them up correctly. You need to have qualified tab that's actually going to do a good job. You need to train your operators well. It needs to have some commissioning that's done correctly, no matter who does it. And as-built and O&Ms are good. So that's all the contractor needs to do. And then we need the operators going to come on, and this is going to be operations management. And of course, they're going to be selected over here and work by per the OPR. And they're going to get systems over here to operate that are developed in the OPR. Performance tracking system. Most buildings don't have this, but they should. They're going to have operators. They're going to do maintenance. They're going to have their CMS system and operate the building. So these are the different components within a building. And the reason it's hard to get performance, the only person that touches all of these is the owner. So if the owner does not have expertise in how to make a building work correctly, then there's no chance, because these people are all working their own silo. They don't cross the silos very often. Only the owner does. So if the owner has, and some large commercial or industrial owners have people that are capable of doing this because they can't get it without it. So they have to have people on their staff that can manage, commission, test, check, and knows everything about everything in a building to be able to get good performance. There aren't many of those people around, unfortunately. So project components for contracts. So you have an owner, and of course he gets the design, and the design team does the energy model. And then the owner selects the contractors, and the contractors does the electrical, mechanical, engineering. All this stuff is done here. So the owner then does the contractor, which has the building enclosure, the mechanical, the electrical controls, and tab. All these things make performance work, and the owner selects somebody to do that. And then we have a commissioner, normally works for the owner directly, a commissioning firm to actually try to commission these activities. And we have operations over here, which is normally only the owner is involved in. So the problem here is we have the possibility of 4 different silos in our contracts. We have an engineering design contract, which happens early on before these people are there. And then we do a construction contract that they don't have anything to say about the design, because if they're bid build, then they're design bid build, and they just bid to the design. And then commissioner comes along, and normally he's coming after the fact about, he should be up here, but normally he comes right around in here. And he has some opportunity to talk about design. However, a lot of designers pretty much ignore whatever a commissioner says. And then, of course, operations the owner. So we have these 4 silos. Well, if you want a performing building, you need to have all four silos working together. And that's the problem, because we don't have that. So guaranteed performance contracts actually have an owner, and then they put all of these things into one pile with one person responsibility for all this thing to happen. So the owner ends up with what he wants. This is normally a design, build, or cement risk type contract. We have contracts out there that include operations. There's not many, but a few. But if you want to have everything work, you got to put them in the same silo. If you only put through CX testing, like we do most of the time, and operations outside of it, then you can't hold anybody accountable, because the operations have 90% effect on the performance of the building. So this has to be included for the measurement period. So single contract responsibility for performance is absolutely mandatory to get performance. So here's what I call a total responsibility contract for a guaranteed performance. Basically, you have a contractor that's a cement risk or design build, and he has the responsibility for the design, the energy model, the construction, the test and balance, the commissioning, and a year of operations. And this year of operations is our period to prove performance. So we're proving performance, and then of course we have a warranty period after proven performance. So what happens here is the building is actually occupied right here, and this is our performance tracking period. And at the end of the performance tracking period, the owner will accept the building if it meets the performance values. And then, of course, the final payments are made. So that's just what's happened. So it's a little longer contract. And what is really sweet about this contract is during this operations, all these contractors are still involved. They're actually performing the maintenance and key operations within this period. So they know firsthand what's going on, and they have firsthand to operate this the way it's supposed, because they're the ones that actually installed it. Your tab guy is still involved as needed, and the commissioning guy is still needed during this period. So everybody's there that needs to be involved, including the designers, to make this actually work correctly. We also use this period to train the owner's operators. So he may not have a full staff because he doesn't need it, because we have the contractors helping. But this is a really great training event. So you have a whole year to really train the operators how to run the performance of the building. And that's it. So it's got design, the model. These are all the things that really matter. You know, if you don't model a building correctly, now people don't pay much attention to this, but if you are a lead building guy and you watch how they do this, you know there's a problem here, because they give points by how well your model says you're going to predict you operate. So you take a base model, you compare it to your model, and the difference is what you get points on. And a lot of modelers push that difference. So they say, oh yeah, it's going to be much better, and end up with a model that's too optimistic. That's not what you want. You want a realistic model, not optimism. So it's really important that the model be included in. And of course, you have construction of all the building. You have commissioning, tab and commissioning, which is really, really important to make sure it works correctly. First year of operations, of course, this is our testing period and our final proof of performance. And this whole thing together is where we get our proven performance. Contractors who have the most impact on performance. You know, there are some contractors that have absolutely almost no impact on performance, like the flooring contractor or the painting contractor. They don't have much, or the parking lot contractors. Now, they're important, but they're not key to building performance. But who is? The designer, absolutely key to performance. Energy modeler, really important that he has not an optimistic, but a practical, conservative, realistic model. Energy enclosure subcontractors, so we have a quality enclosure, and we prefer it to actually be tested. Mechanical subcontractor has to be able to know what he's doing and do it correctly. And we have electrical, the same thing. It needs to be quality construction. Control subcontractors. Now, control contractors get blamed for a lot of stuff, but rightfully so, because a lot of people, they build their controls and they don't actually finish or actually test everything, and a lot of things don't work correctly, and they have to be. So you got to have a quality control contractor that will help in commissioning, not try to obstruct the commissioning process. Test and balance contractor, like I said, need an accurate balance. They're the least costly sub on the job, and yet have a major importance factor. And of course, your commissioning consultant really matters. And what I propose in this building performance guaranteed is the commissioning consultant is the person that drives performance. You make him responsible for performance in the building, which is a big change, because up till now, commissioners say, I have a lot of responsibility, but I'm not responsible for anything. Nobody works for me, so you can't hold me accountable to anything. We need to change that. We need to make the commissioner accountable for performance. Now, you think it'll chase them away? Well, hopefully it'll chase away those bottom feeders that don't do the job anyway. We don't want them. So let's get a good guy in there that actually is not afraid of making a building work. Trust me, it's totally doable. It's not a problem. Operations subcontractors, whoever's going to operate this building has to be really good. You can't have a schlock, or you can't have a building just operate itself. That's another problem. A lot of people think buildings are all automatic. They're absolutely not. Keys to a successful performance contract. Contractor key success factors are: select a high-quality subcontractor, select highest technical commissioning consultant, select technical operators who understand performance, and then again, task the commissioner with delivering the end performance through all stages of the project. Design assistant review, he needs to be good at this, of helping a designer. He should not be in there trying to disrupt the design, but he should be helping the designer understand. And you understand a lot of times we have really good designers, but they may not have much field experience. They may have never actually tested a building or been in a building, so they may not know. So you want to help them with your field experience, overview the modeling process, and this you just want to help them make sure they get a good basic model that's a realistic model and not push the numbers to make everybody look good, because it will not in the end. In the end, it'll bite you. Construction observation and system testing. Make sure we help the contractors build a building correctly and catch it early so they can finish correctly instead of having to redo anything. Final system commissioning and optimization. We want to make sure that not only have we built the building the way it was supposed to be by the design, but we've actually optimized it beyond that of what the actual feedback within the system really is. Supervision and tracking management, system management during the performance tracking period. We want to manage that process of using that tracking system. So a total responsibility contract includes the design responsibility, modeling, includes all construction, includes commissioning, includes performance tracking system. May actually include an analytic data software package. May not, because they are expensive, but if it's included, that will help. Includes 1 year of optimization for operation for performance verification. Performance is proven at the end of the performance tracking and verification period. So normally during the normal contract like this one, the general contractor's retention would be 10%. 5% retention, 5% retention. So normally that occupancy will reduce that, or maybe a little earlier than reduce it down to 5%, but we're going to hold 5% retention until you've proved performance. 10 to 20% performance on subcontractors. Now, this is just my recommendation, but if you have subcontractors that are really key to performance, we need to hold a little bit more retention. Now, 20% is pretty high, but you'd get their attention, and it may actually make your job cost a little bit more, but at the end I'm going to talk about costs. But if you have to pay 10% more for a contract that's going to do a quality job, it's going to be well worth it. I know that I'm going against a trend of low-cost construction, but the retention, I would up the retention so you have, just to wake them up. At the end of the day, it's not enough to actually fix this building. By the way, this 5% is I can fix anything. I can fix anything for $1.50 a square foot. So basically, this is way more money you need. This is enough to get people's attention, and that's what you're trying to do. Contract ends when performance is achieved at the end of the performance period, measurement period. So here's that period. So we have the design, energy model, construction tab, and the CX testing. And then we have operations. This is our performance measurement period. This is operations for a year. So this is why the contract is 1 year longer than a normal contract, because we're tracking this through the different seasons. And we normally end at that first year. It's all along, and we see that we're beating our performance numbers all along. We know we're going to reach this without a problem. We'll be happy campers. And then it enters a standard warranty period. This is no different than a regular contract except for this operations period. And again, during this operations period, the contractors are operating and maintaining the systems. And these are the guys that actually started it up and tested it. They know exactly how to do that, and they're in there operating it. Now, normally the owner puts operators in here, and the contractors bring people in and out to do what's needed for maintenance and do it for major operations. Or if it's a big enough building, they may have some staff that are 100% time here during this period, depending how big a building it is. But remember, this allows the contractors to fully train an operator. By the time this 1 year's over, these operators should know exactly how to do everything in that building. So this is a performance contract performance. And this is, I guarantee this will work. Commissioner manages the performance issues, so the commissioner is involved from day one to day end. Now, if it doesn't work, we'll talk about that. So the commissioner manages every aspect of this so that he's responsible for delivering the performance. Now, what this means is that now all of a sudden people are going to pay attention to what the commissioner says, because if they don't, he has a way out, and you don't want to provide that. So the designer should listen to him, the contractor should listen to him, and everybody doing the commissioning should listen to the commissioner, because he's responsible for it. So he now has, he used to have just responsibility, he had no responsibility, now he has responsibility, and you're going to hold him accountable. So how do you actually make this work? Well, we have developed different project specifications that actually define what performance is. The main one is Guaranteed Performance Project Scope. 109 is the design requirements for performance. The energy building and modeling requirements. 800, 8,000 is demonstrated performance. 183,000 is enclosure performance. 92,000 facility operation requirements. 9313 is facility requirements. 9113 is commissioning performance requirements. 220850 is plumbing. Tab performance. Performance tracking system performance. 230850 HVAC performance requirements. HV control performance requirements. FDD analytic system requirements. Water treatment performance requirements. Electrical performance requirements. So there's a lot of those systems, and what we did is we wrote those spec sections that actually define this is what a contractor needs to do for final performance of the building, and it explains out to him, this is how you're going to operate during construction, this is how you're going to operate during operation measurement period, and this is what you're responsible for, and this is how it all works. So they understand. So now they've got a document in writing that tells them what this job's going to do and what their part is in it. Performance measurement for each month of operation performance is measured to predicted performance. Because, the engineer actually does a model that actually calculates all this by month. Some of them do it by hour. So they have enough data that we can do this easily. The original energy and water use models are rerun for normalization of actual weather, occupancy, and schedule per month to compare predicted to actual results. So we don't want some outside factor skewing the results, so we're either rewarded or penalized for that. So we're going to take the model and we're going to normalize it for that data to see whether we're ahead or behind. And we should be able to do that without problems. Now what this does is it alerts us really early. Wow, this month's way off. We got a problem. We got to figure it out. And that's what allows us to get to the end of this measurement period and actually be where we need to be. If we just waited 12 months to see where we're at, big problem. Goal is achieve predicted energy and water usage values with no more than a 10% variance. It can't be perfect, so we're going to either be better or worse. We don't really care if we're better, but we don't want to be much more than 10% worse. And that's a goal. The second goal is to achieve the design interior ambient conditions for occupant comfort and productivity. In other words, we're going to run this building in strict compliance with the OPR. So now that makes it much more important that the owner produce a real OPR, not just a fake document. But we need to know exactly what we're supposed to do in this building. If we say we're supposed to maintain 75 degrees, that's what we're going to be evaluating on now. You're not going to change it to 80 degrees just because it's easier to do. Some states it might be harder to do, but so if performance is not demonstrated, so it doesn't work, what happens? Well, if the results are not demonstrated, then the contractor continue to operate and improve the system performance until the required goals are reached. So we're going to extend that operational period out up to 12 months, not over that. It could be shorter, but it can't be longer than that, because at that period, if we can't make it work, there's something going on. So the commissioners, the designers, the operators, and contractors strive to adjust system parameters to provide performance. So we'll go in and do what we have to make that actually work. Demonstrated performance for any 2 measurement periods during the cooling season and 2 measurement periods during the heating season will complete the contract. So in other words, we have 12 months to prove that 2 months in summer and 2 months in winter work. And if we get 2 months, with those 4 months show work, then we're done. So we don't have to wait a whole year. But we need 2 months because 1 month could be just a fluke. We don't want to do that. Now again, remember we're rerunning the model to make sure that we've normalized everything to tell that. So if the performance is not demonstrated, then what happens here at the end, so this is our measured performance and it failed. So at the end of that 12 months, if we can't make it work, then there's another 12 months available to continue to make it work. Now, to be quite truthful, we should not need that, because going through this operation period, we know it's going to fail. I mean, you're not going to go really good for 11 months and fail the 12 months. No, you're going to see it long here. So we should have been making corrections during this period to up that, so when we get here, we're in good shape. Now, if we're beyond the 10% and we just need a couple of months to prove ourselves, then we can go into this period to do that. But there should be no reason to make this 12 months. if we make this 12 months, it means it's not going to work. So what happens then? And then, of course, the warranty is based after once the building is accepted, the warranty starts. If at the end of the warranty period performance cannot be demonstrated, this is the worst if it could possibly happen. The contractor, the commissioner, designers, and operators provide a report clearly defining why performance cannot be achieved. There's got to be a reason. If we find a reason that was not, someone missed something, we didn't see it, or there's some extraordinary circumstances, then at this point, the contractor and owner negotiate a settlement. It may be that the owner just says, okay, we're all right, let's go, or it may be we need some compensation, and that may be that. So there's negating circumstances that could actually cause us not to get there, which is going to just negate this problem, and the contractor's off the hook. Revised OPR instruction changed by the owner. So if during the process the owner changed the OPR, that's a problem. Now you can add to it, clarify things, but you can't make a major change because we've based the design, we've based everything on that OPR, and if you change that, we're doomed to failure. Failure of the owner to allow access. If the owner doesn't allow us access to operate this building, then that has to be a problem. If the owner's personnel change operating parameters that negatively impact performance without approval. So we're going to be there, but if they make a change that we didn't approve and kills the performance, that's on the owner. Occupant actions that negatively impact performance. Anything the occupant does, occupant decides they want to leave all the doors open. It's all right, pal. That's not our problem. That needs to be operated as a normal building. Now, this has been done a couple of times. One project I followed, I've been trying to sell this for years, but no one's ever bought it, but I would like to. But there was a federal courthouse in, I believe it's up in Seattle, that they decided to do this. Now, they didn't do my system. They just went out and said, look, we're going to find a contractor who's going to guarantee their work, and that's all. They didn't put anything in the contract that explains how that works. They just did it. And, of course, at the end of the project, it didn't work. So they were 30% out on performance. So the designer came back, and the testing contractors came back, and they worked for 2 months trying to figure it out, but they did get it within 10% at the time. But they had to come and actually do it because their normal work processes did not deliver performance building. And that's unfortunate. So they weren't structured like I'm recommending, but I know this is possible to do because I've retro-commissioned many jobs and saved them tons of money on operations, and most of the retro-commissioning projects have all been done to actually make the building work. It's not working, and so we've done that. So I know this is possible to do. It's not that hard to do, just paying attention. So remember, need a quality design, accurate energy modeling, quality construction, expert tab, technical commissioning, effective owner training, performance tracking systems, effective operations. Those are all things that are needed. Low cost or scheduled compaction cannot offset these key values. These are the values that drive performance. And if we defeat any of these, we're going to defeat performance. Okay, what does it do for an owner? Well, one, the owner gets demonstrated proven building performance. So he's got a building he absolutely knows performs because it did. Building constructed to a higher quality standard. He gets a better building. Performance tracking system up and running, so he's got a system to keep it going in the future. Fully developed CMMS system, that's what we're normally charged with during the performance period, is setting up that system. Fully trained operators, operating tools and procedures are in place to maintain future performance, so his persistence is vastly improved. Cost of first year of operations is included in the capital budget, not the operation budget. That's one thing that I did this early on when I was a contractor. We did some jobs like this, but we did it on our own without this system. And what we realized, because of smart owners figured this out for me, is that when we were operating the building for that first year, that cost, they didn't have that cost. It was in their mortgage costs. So the way the valuation of a building works is based on cash flow on a lease building. So if their first year of operations was in their mortgage payments, it showed up in their cash flow. So their building was valued much higher. So they loved it because they now could, if they could sell a building in the first year, they made out like a bandit. So I thought that was an interesting process that I wasn't smart enough to figure out. lower future operating costs. This is absolutely true, and it's what the owner should be doing this for. Contractor. What about contractors? People said, man, you're not going to be able to find a contractor that'll take that, and that's not true. I have talked to some of the largest contractors in the United States, and they're excited to do this. And I ask, why? Well, this is why. Improve contractor marketing profile, which provide additional sales opportunities for the future. It says, if I can go to an owner and tell him I guarantee this building will work, it says I'm up on the ladder. It says my competitors won't do that. Good, because I've got an advantage. Improved quality process provided a higher quality building with much lower warranty costs. I've experienced this directly. A fully building that works, that's commissioned fully, has almost no warranty. And as a contractor, I've seen that in my own projects. When I started commissioning my own projects, my warranty costs went to zero. Total responsibility contract provides more revenue. They're going to get more revenue. Higher customer satisfaction with constructed results, which is obvious. So why performance matters? Okay, here's a cost example. This is a fictitious project. It's not a real project, so some of these numbers may be off a little bit, but it doesn't matter. It's the concept I want to get you aware of. This building is basically a 100,000 square foot standard office building, 12 hours, 5-day operation, 250 square foot per occupant. National average ambient conditions, national average cost, conservative utility cost of 15 cents a kW, $4.50 per 1,000 gallons of water. Now, this is 3 or 4 years old, so there's a change, obviously. National average for CO2 produced. That's, of course, a big thing right now. So here's what this chart looks like. This is the construction. This is all the costs to operate the building over 10 years. So we have our 120 months here. So going out this time for 10 years. And these are all the different costs I've done. You know, this is the construction costs. Light blue is janitorial costs, utility cost. Water cost is red. You can't even see that. Administrative management, how much it costs to administrate the building. Repairs and maintenance. Insurance. Operations. Utility energy. This is utility energy. And taxes up here at the top. And this is just, these get bigger because they're to-date numbers. So they grow as you go through the year. So we've got upwards of, I think we're here at $20 million or so for build a building. And we're up right around $10 million to operate it for 10 years. So this is kind of the performance of here. You see the design was $214 a square foot. And we get escalation, and over the 10-year period, we're up to $445 a square foot. So this is about a 200% escalation over the 10-year period. And what we're saying is that this is a standard. It's pretty well standard to not make your design, and these kind of numbers is basically 30%, and it continues to grow. So that's what a normal building without guaranteed performance would look like. And this would be one with performance. So here we see that we have the same thing. We have a guaranteed performance building. It's efficiency, persistence, escalation, held to utility increase only, not degradation in performance. More comfortable building, happier tenants, higher value asset. You know, if you have a building that everyone's really happy with and it works well, utilities are low, you have a better asset. You can sell it for more money than if you have an asset that doesn't have those values. So here kind of is my little take on this. This is the additional cost. So if you have a cost, it's going to cost you $496,171 to build a building. Additional cost of this $20 million, because this is the things that are going to cost you a little bit more. This is the operator for the first year, might cost you an extra $50,000. And then that's a total of $546,000. The utility cost for 10 years with a GPC building, which is $1,619,000, which is an average year. So your simple payback is about 3.37 years of what you spent up here to build a building. But if you do it over 10 years, you get a lot more. So basically, is it worth it? Would you invest $546,000 to save, one, to have happy clients, and two, to save $1.6 million? This is your total savings over 10 years, which is like a 9% return on your money. So, you know, it's not like payback in months, but it does pay back in years, and it definitely is absolutely worth it on a financial cost basis. So sustainability, if you want to talk about CO2, the difference, this is a CO2 of a standard building. I'm sorry, this is the CO2 of a standard building. This is CO2 of a GPC building. So you do save some tonnage. You save about 9,800 tons of CO2. That's not a lot, but you do save much because your systems run more efficiently. So can you be sustainable without performance? That's a question. You know, we have a lot of buildings out there that have some real pretty plaques on the wall that aren't working well at all, but yet they still have the plaque. They don't take the plaque away from you, unfortunately, if you don't have a well operating building. So a GPC will give you that correctly operating building. I hope this has been informative for you. I hope you have an interest. If you do, send me a note and we can talk. All right, thanks. Thanks a lot for getting through this with me. GPC has been a concept of mine for the last 4 or 5 years, and I would really like to see this become a standard in the industry to actually achieve our energy goals. Thanks for watching. Thanks for being a subscriber. Have a great day, and I'll catch you on the next one.